Saxon Algebra Lesson 57, Finding the Least Common Multiple. The least common multiple is a number that is evenly divisible by each of the numbers in a set. The least common multiple is actually a big number. It's not going to be a number that's smaller than the numbers in the sets. Sometimes we get confused by the word least. Remember, it's opposite, that it's a bigger number. When finding the least common multiple, it's easy to use steps to find the answer. Let's do step 1. First step is the factor tree. Let's take a look at example 1, 24 and 36. Remember, the factor tree is where we break numbers down into prime numbers. Let's break 24 down first. 2 times 12 equals 24. 2's prime, let's break down 12. 2 times 6, 2's prime, let's break down 6, which is 2 times 3. Both those numbers are prime. Let's break down 36. 36. 3 times 12. 2 times 6. 2 times 3. Step 2. Find numbers that match. I wrote 24 and 36 with their prime numbers written out next to them so we can see the numbers clearly. Step 2, like I said, was find numbers that match. If you notice, the 2's match in 24 and in 36. In the parentheses, it says the greater numbers of times that it appears is what we use to find the least common multiple. What that means is that we have 3 2's in 24 and 2 2's in 36. Which number has the most 2's? The 24 does because it has 3. So we'll use those 3 2's to find the least common multiple. Do you see any other numbers that match? You're right, the 3's match. We have 1 in 24 and 2 in 36. And of course, we use the amount of 3's that shows the most, which would be the 2 3's in 36. Step 3. This is the very last step before we actually get our answer. We use all numbers that don't match. If you look at our prime numbers, you'll notice that we actually have no numbers that don't match. The 2's match and the 3's match, so there's no other numbers to add to our answer. So to get our final answer, we take the numbers that match and multiply them together. 2 times 2 times 2 times 3 times 3. You'll end up getting 72. Now that we have all 3 steps, let's do another example with just numbers included. Remember that we have to follow the steps to get the correct answer. Step 1, factor tree. In this example, we have 11, 12, and 18. 11. Break it down to prime numbers. But if you notice, 11 is already prime. 12. 2 and 6, 2 and 3. 18. 2 times 9, 3 times 3. That's it for step 1. Let's move on to step 2, which is you find the numbers that match. There are 3 numbers in this example. It is okay to use only 2 in the matching numbers. For example, 12 and 18. They both have 2's. And which one has the most 2's? The 12 does. So the 2 2's would come over as part of your answer. The 3's also match. The 18 has the most 3's, which is 2, so that comes over as part of your answer. And of course, the last step is step 3, which is any numbers that don't match at all. What number do you see that doesn't match? The 11. Let's circle that number. That one doesn't match any of these other numbers, so we bring it over as part of our answer. Now that we have all the numbers that match and also the numbers that don't match, we multiply them together to get our final answer. 11 times 2 times 2 times 3 times 3 will get us 396. 396 is a number that 11 can be divided into, 12 can be divided into, and 18 can be divided into. It is a big number. Let's move on to the next example. Example 3. 10a squared c to the 4th and 15a cubed c cubed. We follow the same exact rules that we did before, even with variables. Let's go ahead and do the factor tree first. The 10. 5 times 2. When we look at our variables of a squared c to the 4th, all we're doing is writing it out just as it's shown. So it says a squared, so we write 2 a's. C to the 4th, rewrite 4 c's. And do the same for 15. Alright, once we get done doing the factor tree, we follow the same rules as we did before for step 2 and step 3. Let's do the numbers first. Let's find the numbers that match. 5 matches. And if you notice, there's not one that has a higher number of 5's. So all we do is take 1 because that's all that's actually shown in both. All right, are there any other numbers that match? There's not. So step 3 is numbers that don't match. 2 doesn't match anything in 15, and 3 doesn't match anything in 10. So we bring that down as our answer. Let's move on to variables. Which variables match? The a's and the c's. Which number has the most a's? The 15 does. It has a to the 3rd, so we bring a to the 3rd down. All right, what about the c's? 10 has the most c's with 4, so we bring c to the 4th down. All right? So now that we have our numbers and our variables, to get our final answer, all we do is multiply the numbers. 5 times 2 is 10, times 3 is 30. And the variables stay the same. And that is our answer. In this very last example, we're finding the least common multiple of these two binomials. But don't get scared. The very first step for this is going ahead and factor out numbers or variables. Then we'll find the least common multiple. Let's go ahead and factor out 7x squared plus 21x. What number can be factored out of 7 and 21? 7 can, because 7 can go into itself and 7 can go into 21. So 7 can be factored out. All right, what about a variable? We have x squared and x. So how many can be factored out of that equation? Because 7x squared only has 2 x's and 21x only has 1, only 1 can be factored, which will leave us inside the parentheses x plus 3. And the reason why x is left is because 7 can go into itself one time, and we took 1x out, which will leave it x left. Plus, 7 will go into 21 3 times. We took that 1x out, leaving no x's left. Go ahead and break down 6x plus 18. When it's completely factored, we end up getting 6 parentheses x plus 3. Now, when we factor these down, just like we did before into our factor tree, the x plus b in both binomials stay as a normal variable by itself. So 7 is already prime. So we have 7x x plus 3. We break that down into 7 times x plus 3. All right, the factor tree of 6 is 2 times 3. So when we write that out, we're going to break it down just like we did before. 2 times 3 times x plus 3. So we have the factor tree of our first binomial and the factor tree of our second binomial, and follow the same rules that apply. What are numbers that match? If you notice, the x plus 3 matches. So that's the binomial that matches, and because there's one of each, 1 is part of our answer. How about 7x and 2 and 3? Do any of those match? They don't. And according to step 3, we take anything that doesn't match and make it part of our answer. 7 times 2 times 3 times x. Then we multiply all the numbers to get our answer. 7 times 2 is 14. 14 times 3 is 42. 42x, x plus